Hey guys. So for some of us in class, we didn't get through the whole thing. So I just want to kind of recap the exercises 3, 4, and 5. So some of you just didn't get the last one. Some of you didn't get any of them. So I just want to make sure that you all have them. So you can skip around in this video to the part that you need. Okay. So in this first one here, we're setting up our statement and reason. Right. The only given we have is that M is parallel to N. And we're trying to prove that angles 1 and 3 are supplementary. So when you have parallel lines, we automatically have the arrow here. That arrow is the indicator of them being parallel, not congruent, just parallel. But then you can look for your Z pattern that we have here because these angles 1 and 2 are on there. So those angles 1 and 2 are my alternate interior angles. So once I have parallel lines, I automatically know I have alternate interior angles. So angle 1 congruent to angle 2, parallel lines form congruent alternate interior angles. So it's similar to when you were writing the perpendicular lines, right? Perpendicular lines we automatically know form congruent right angles. We write it that same setup. So we have a pair of angles. We also should notice here that angles 2 and 3 add up to 180 degrees. Right? We know that they are angles on a line. So that means they're supplementary. Now, with this part being said here, we already had angles 1 and 2 being congruent. So I'm going to take angle 2 and I'm just going to replace it with this angle 1 to have angle 1 plus angle 3 equal to 180 degrees by substitution. Now, I could go on for an extra step and say angle 1 and angle 3 are supplementary, but I think we're pretty much covered here because we know that to be supplementary, it means two angles that add to 180. I've shown that, so I'm going to say we're okay in this one. Now, here's something that's more likely of what we could see, right? We have our given, and we're trying to prove the two triangles are congruent, just like we've been doing the last couple weeks now. So AB is parallel to DC, and AD is parallel to BC. So those are two different pairs of sides, right? So I'm going to mark them in here. AB is parallel to DC, so they get the one pair of arrows. Then the second pair would get two, AD and BC. So those are my indicator of which ones are parallel. And I'm trying to make my plan here, right? I'm trying to prove that ABD, this triangle, is congruent to triangle BDC in here. So automatically we should notice our overlap, right? So we see BD congruent to BD, and that's just our reflexive. So that's something we've known, and that's our first pair of angles or sides, right? So we have a side for these. Now, because I have parallel, in this case, I should notice that I have a Z shape, right? And that Z shape leads me to the angles in between. So my angles 3 and 5 are going to be congruent. Okay, again, my reasoning here is parallel lines form congruent alternate interior angles. Okay, but also I have that backward Z as well. So I mean, if I'm going from this parallel pair, I should also see it in there. So I really have 2 and 4 also congruent. So I'm going to squeeze that on that same step. So there's my 2 pairs of angles. Notice they were on each piece of the side. So at each end of the side, we have an angle and an angle. That means we are ready to prove that triangle ABD is congruent to triangle CDB by angle side angle here. So I've just proved the triangles with angle, side, angle. So we already know how to prove triangles. It's still the same thought process. We just have an extra tool now. So when you see parallel in here, we can potentially have congruent alternate interior angles if we see that Z pattern, right? Now in the next one, that last one here, we have the two triangles, pretty straightforward, which ones we're trying to prove, right? We prove the triangles, then we can do CP, CTC for that last part. So in here, I know I have a line segment ABC. We know that BD is parallel to AE. I know that B is the midpoint of AC. And we can squeeze angle 1 is congruent to angle 2 in here also. And that's all my given information. So when I'm looking at the two triangles here, I already have 1 and 2, so they're in the triangle, so I have one pair of angles already. Now, we know as soon as we see that word midpoint, cuts it in half, so we don't even think about that one anymore. We have AB is congruent to BC, midpoints, cut in half, right? Create two congruent segments, something along those lines. But so there's my side. Now, we got to look at this one. So as I'm looking in here, I know that I'm talking about, we were given that BD is parallel to AE. So I might extend my line a little bit so you can look a little bit like what we're used to. Because then here's my transversal. So when I extend this, I don't see anything on the Z pattern, right? Like if I look at a Z here, I'd have this angle and this angle, which only one of them's in the triangle. So I don't want that. Okay, even if I try this, same thing, only one is in the triangle, not going to help me for my proof. Instead, there was another type of angle that we could use to prove. So we have the angles that are inside and outside along the same transversal, right? On the same side of that transversal, I'm going to call this angle 3 and angle 4. So I know angle 3 is congruent to angle 4 because they are corresponding angles. So it's the other type of angle a parallel line forms. So parallel lines form congruent corresponding angles. So it's important not to just get the habit of alternate interior, even though that one probably does come up more often, because this was a case of corresponding angles. And so now I know my triangles are congruent. I have triangle BCD congruent to triangle ABE. Another one of angle, side, angle, because if I look, that other angle is on the other end of the side. And once I have the triangles congruent, we know we can set any pair of angles or sides congruent. So angle D congruent to angle E by CPCTC. Okay, so we put those angles that we wanted in here. So in this case, really all that we were doing a little bit extra today was we're bringing back parallel lines and we're using them in our proofs when it's appropriate. So if we can use it in our proofs here, we definitely want to prove the triangles or whatever with that. Okay, just be careful to make sure you set it up as parallel lines form congruent, either alternate interior or corresponding. Okay, in tonight's video for homework, you'll see that there is a way to prove that the lines are parallel. So that's where we're going to keep going. And then we're going to do practice tomorrow in class. Okay, so definitely come in with questions and I'll see you guys then.